Welcome back to my channel. Now listen, this topic is one of the most it's one of the compulsory topics you will see questions from in the Jamb. Are you getting it? You will see a lot of questions from this particular topic, electric field in physics. Are you getting it? Electric field in physics. And it's under series and parallel connection. Are you getting it? Series and parallel connection. So please, when I'm teaching, listen carefully. Are you getting it? Because we see a lot of questions from this particular topic, series and parallel connection. Okay. Now, the first thing is most students cannot identify which one is series connection and which one is parallel connection. Are you getting it? So this is one of the most important thing we have to learn before going into the calculation aspect. Are you getting it? Now, this is how to identify which one is in series connection and which one is in parallel connection. Are you getting it? Look at the first diagram. This first diagram is in series connection. Look at the resistors. We have three resistors here. Resistors 1, 2, and 3. Right? It's in what? Horizontal form. Are you getting it? It's in what? Horizontal form. So anywhere you see a connection in this form is in what? Series connection. So this one is what? Series. That's spell it well. Series. Okay. This one is what? In series connection. Why this one? Look at the resistors. They are parallel to each other. When we talk about parallel, okay, let me draw this line. This one line, a straight line, right? This another straight line, this another straight line. Okay, let me end there. Now, meaning that, okay, let me just draw only two lines. Meaning that these two lines, listen carefully, these two lines are facing each other but in opposite direction, isn't it? And these two lines too, are they not facing each other? They are facing each other, right? Meaning that they are in what? In parallel. Are you getting it? They are what? Facing each other at the same time. They are what? They are what? They are called parallel or lines. Okay, parallel lines. I get it. But they are in what? Opposite direction. This one is in the right direction, while this one is in the left direction. But they are, so if you see any two lines facing each other in this form, any direction, either in this form or in this form, they are what? Parallel lines. Are you getting it? So meaning that this, we have resistor 1, resistor 2, and what? Resistor 3, right? So meaning that this connection is what? In parallel connection. Parallel connection. Are you getting it? So I believe right now you can identify which one is in series connection and which one is in parallel connection, right? Now we have different ways of solving them. Are you getting it? There is a pattern which we use in solving questions under series connection and parallel connection. Are you getting it? So, okay. Okay, now listen. Let's start from the series connection. Are you getting it? Let's start from the series connection. Now, if you are asked, listen though, if you are asked what is the equivalent of this connection, this one is in series connection, isn't it? So if you are asked what is the equivalent resistance in this connection, this is how to calculate questions under series. So this is what we do. The equivalent resistance, okay, you can put either n here, okay, then R equal to, we have this in three resistors, right? 1, 2, 3. So R1 plus R2 plus R3. Let me come here so you see it clearly. So are you seeing it now? So this connection is in what? In series connection. This is how to calculate questions under what? Series. Are you getting it now? So all of them are in what? Horizontal form. Just this is a what? The total. So this one, the equivalent resistance means what? The total resistance. Are you getting it? So don't be confused with the grammar. Are you getting it? So in some questions, they might ask you to calculate what is the total resistance or what is the equivalent resistance. Are you getting it? So the total resistance here is what? the first register plus the second one plus the third one. Are you getting it now? Okay, then let's come to the parallel connection. Are you getting it? Let's come to the parallel connection. Now, if you are asked what is the total resistance here, or what is the equivalent resistance in this parallel connection, this is what we do. 1 all over R equal to, how many resistors do we have? 1, 2, 3, right? 1 all over R equal to 1 all over R1 plus 1 all over R2 plus 1 all over R3. Are you getting it now? So you can see that calculations in series connection and in parallel connection, they are what? Very different. Are you getting it? So if the connection is in series, this is how to calculate them. It's very simple, okay? But if the diagram is in parallel connection, this is how to calculate them, okay? 1 all over R equal to 1 all over R1 plus the second one plus 1 all over the third register. Understood? From this understanding, let's solve some examples so you will understand how to apply them when you see it in the exam. Okay, 3 registers of resistance, 1 ohm. Please, I forgot, the unit for resistance is ohm. Okay, ohms, and the symbol is in this form. Are you getting it? So this is the resistance. So this is the unit of resistance, okay, ohms, and this is a symbol. So anywhere you see this symbol is referring to what? Resistance. Are you getting it? Now, some questions will be in the diagram form, while some will be in this form. I get it. But in all the questions, they will indicate if this one is series or parallel. I get it. So after we've done calculating this one, we go back, we do some examples under the diagram form. Okay. Now we are given how many? We are given 3 resistors, right? 1 ohm, 2 ohm, and 4 ohm are connected in series. Are you getting it now? They are connected in series. Find the equivalent resistance of the combination. So what did I said about series connection? I said now from this question they said in series form, right? They said find the equivalent resistance of the combination. So we do what? The equivalent resistance is what? R equal to what? The first resistor plus what? The second resistor plus the third resistor, right? Now, which one is the first one? The first one is 1, right? So equal to 1 plus the second one is what? Is 2 plus the third one is what? Is 4. So if you add everything together, 1 plus 2 is what? Is 3. 3 plus 4 is what? Is 7. Don't forget the unit. So this is the answer. So you see that question under series is very simple, right? So this is how to calculate questions under series connection. Are you getting it? Okay, let's do another example. Okay, so this is the second example. Let's read the question together. If 3 resistors, right? 2 ohm, that is the first resistor, 3 ohm, that is the second resistor, and what? 5 ohm, that is the third resistor, right? Are connected in what? In parallel. They are connected in parallel in a circuit. Calculate the equivalent resistance of the combination. Now, the first one we calculated is what? It was under series, right? This one is under what? Parallel. Are you getting it? Now they said we should what? Calculate the equivalent resistance. So this is what we do, right? R equal to what? Sorry, 1 all over R equal to what? 1 all over the first resistor plus 1 all over the second, then the third one. Isn't it? So equal to 1 all over the first resistor is what? Is 2 plus the second one is what? Is 3 plus the third one is what? Is 5. Are you getting it? Now, this is where most students will be confused. they won't even know where to start from again. We have half 1 over 2 plus 1 over 3 plus 1 over 5. Where I go start from now? Almost confusing. It's very simple. Now the first thing, listen carefully. I want to explain something now. The first thing you need to do is to find the LCM of the denominators. Are you getting it? The LCM of the denominators. And what are the denominators? We have 2, 3, and 5. And the denominators are what? 2, 3, and 5. These are the three denominators we have, right? You know how to find LCM now, isn't it? Okay, let's do it this way. We have 2, 3, and 5. What can go? 2 can go, right? 2 to 2 is 1. 2 cannot go here. 3, 5. What can go? 3 can go 1, 1, 5. What can go? 5, 1, 1, 1. Isn't it? So you just multiply everything together. 2 times 3 is what? Is 6. 6 times 5 is what? Is 30, right? So meaning that the LCM is what? Is 30. Please listen carefully, okay? Now, the second thing to do is what? Is to use the LCM to divide each of the denominators and use the answer to multiply each of the numerators. It's very simple. This is what it means. Now, this is the LCM now, isn't it? It's 30, right? 30 divided by 2 is what? Is 15. 15 times 1 is 15. So you write 15 plus. Let's come to the second one. 30 divided by 3 is what? Is 10. Then 10 times 1 is what? Is still 10. Plus, let's come to the fifth one. 30 divided by 5 is what? Is 6. 6 times 1 is what? Still 6. Now let's add everything together. 15 plus 10, 25, plus this one is what? 31. So we have 31 all over 30. Now, don't rush. Are you getting it? I know most of you, once you solve to this point, you just press your calculator. 31 divided by 30, you will get the wrong answer. But still yet, you will see the answer in the options in the exam. Now, listen, this is what you should understand. Once you solve to this last part, don't rush and press your calculator. 31 divided by 30, you will get the wrong answer. But still yet, you will see the answer in the options. Are you getting it? But that is not the correct answer. That is jam for you, okay? Once you solve to this extent, what you should do, what you should what? Interchange them. Are you getting it? You will what? Interchange them. You will bring what? The denominator upward and bring the numerator downward. So you will have what? 30 all over 31. Are you getting it now? So if you press your calculator, so the answer will be 0.97. And what is the unit of resistance? Is what? Is ohm. So this is the final answer. Please, this is the answer. So this is how to calculate equations under parallel. Okay. Now, let's go to the diagram aspect. I get it. If in case you are given a diagram to solve either the series or the parallel, I get it. So let's move to those calculations. Okay. Now, most of you, once you come across this type of diagram, you say, like this one is in series, or this in connection. No, this one is in parallel connection. No, you can't just conclude that way. Are you getting it? Looking at this diagram, you identify that two resistors are connected in series, while the other ones are connected in parallel. Are you getting it now? Right? These two resistors are connected in series, while these two are connected in what? In parallel. Now, we are asked, they said, calculate the combined resistance. Calculate what? The combined, meaning we are asked to calculate both the series and the parallel, then you add them together. Are you getting it? So it's very simple. So please listen and watch carefully. Now, the first thing to do is to what? Calculate for these two, the resistance of these two resistors, the equivalent resistance of these two resistors. You've known how to calculate for this thing, connection in series now, isn't it? You just to what? Add them together, right? Equal to what? R1 plus R2. So equal to 3 plus 2 equal to what? 5 ohm. So this is the value of what these two resistors in series, right? Now let's calculate for the equivalent resistance of these two resistors. They are connected in parallel, right? Okay, so R equal to what? 1 all over R equal to what? 1 all over R1 plus 1 all over what? R2, right? So equal to 1 all over, the first resistor is what? Is 5, right? 5 plus 1 all over, the second one is 10, right? So what I said in the previous calculation, I said if you come across, like if you solve to this extent, you will find the LCM, right? So what is the LCM of 5 and 10? The LCM of 5 and 10 is what? Is 10. I get me. But if you don't understand, if you want to use that primary school method, you can use it, okay? But the LCM of 5 and 10 is 10. I get me. So what's next? 10 divided by 5 is what? Is 2. Then 2 times 1 is what? 2 plus. Then 10 divided by 10 is what? Is 1. 1 times 1 give us what? 1, right? Right? Then 2 plus 1 is what? Is, so we have 1 all over R equal to what? 3. 2 plus 1 is 3 all over what? 10. Now, the first calculation, I told you that I said you should what? Exchange, right? Now, if you don't want to do it that form, just cross multiply. I get it. Just cross multiply. So we have what? Since we have equal sign at the middle, what we need to do what is to what? Cross multiply. Okay. So 10 times 1 is what? Is 10, right? So 10 times 1 is what? Is 10, right? 10 equal to R times 3 is what? To give us 3R, right? So by making R the shortcut of the formula, R equal to 10 all over what? 3. So are you getting it now? Are you getting it now? But in case if you don't want to this thing cross multiply, just exchange your numbers. That is all. Then this one will automatically what? Eliminated. But please, if you solve to this extent, please just use this procedure. Are you getting it? To be in the safer side. Okay. So we have 10 divided by 3 is what? It will give us 3.3333 to infinity. Okay. If you press your calculator, this is what we have. Now, this is a value of what? The parallel. Why this one is a value of what? This thing, the series, right? Now they say we should calculate the combined resistance, combined. So what we need to do is what? Is to add the two resistance together. That is 5 plus what? 3.333. It will give us 8.333 ohm. Do you understand now? So you see that the calculation is very simple, right? Very simple. Now, if you come across this type of question in the exam, you have to be very fast too. Are you getting it? I'm solving it in this process, like I'm solving it in this form so you understand better. I get it. But if you come across this type of question in the exam, please, you have to be very, very fast with your calculation because we are working with time. Okay, so please take notes. Before I start solving this particular one, please, if you are a student in my lesson group, please listen. If you are a student in my lesson group, after solving this particular one, I will drop a particular question for you guys to solve. Okay, but listen, if I student that is watching this video and you are in my lesson group, make sure after solving that particular one, you should drop your answer on this comment on this comment section and also drop the answer in the interacting group. Are you getting it? Also do what? Drop the answer on the interacting group. Okay. In case you are interested in joining my lesson group, you can comment on the comment section. I will send you my WhatsApp number. Okay. Now look at this particular one. Some students will say, "Oh, this question strong go. Which kind of thing come with this now?" It's very easy. Okay, it's very easy. So don't be confused. Now look at this particular one. You see that these two resistors are connected in parallel, isn't it? Yes, you know that one, Abi. These two are connected in parallel. But where this one they come from now? Where this one they come from? This volt again. You know, this A stands for ampere, and ampere is a unit of what? Electric current, right? Why this one is volt? Volt is a unit of what? Potential difference, right? Volt is a unit of potential difference. Okay. Now look at these formulas. That P stands for electric power. Okay, electric power. And also we can also use this formula when we are calculating for heat, like heat energy symbol, just put H. Are you getting it? If we are calculating for heat energy, we can also what? Use some of these formulas. Like we can use formulas. Are you getting it? We can also use those formulas. So please take note. What is the unit of heat energy? It's in joules, right? The unit of heat energy is what? Joule. That is just J, isn't it? Okay, let's come to this question. They said calculate the total energy developed in 5 minutes. We are given time again. Which kind of question come with this? Hey, they said calculate the total energy developed in 5 minutes by the system above. So the first thing, what are we going to do? You know what to do now. The first thing is to what? Is to solve these two resistors. Are you getting it? Is to what? Solve for these two resistors so that we come out with a single resistance. Now we have been talking about resistance. What is really the meaning of resistance? Do you know friction? Like friction. What is the function of friction? Friction is to what? Oppose motion, right? When you are moving or when a machine is in motion, you notice that friction tries to what? Oppose or restrict the moving machine or the working or the movement of the machine. That is a function of a friction, right? Now, in other words, in the study of electric current or electricity, resistance is also in form of friction, is what opposes the flow of current in an electric circuit. Are you getting it? It opposes what? The flow of current in an electric circuit. Now, so they say what? Calculate the total energy developed in 5 minutes of the system above. So the first thing we do, if you are given this type of diagram where you are having what? Current and what? Volt. Listen to, you notice that these two resistors are connected in parallel, right? So let's solve for these two ones so that we come out with a single what? Resistor or resistance. Are you getting it now? Okay, so what is the formula to calculate for resistors in parallel? You know now. So let's calculate for it. That is 1 all over R equal to 1 all over what? We have 2, right? Yes, we have 2. So 1 all over R2. Okay, so equal to 1 all over. The first one is what? Is 40 plus the second one is also 40. So what are we going to do is to find the LCM. And men looking at it, what is the LCM of 40 and 40? It's still 40. Isn't it? It's still 40. So equal to the LCM is 40. So you know how we are doing it now. So 40 divided by 40 is what? Is 1. 1 times 1 is what? Is 1 plus. Then 40 divided by 40 is still 1. 1 times 1 is what? Is 1. So we have equal to what? 2 all over 40, right? So don't forget we have 1 all over R. 1 all over R equal to 2 all over 40. The next thing to do is what? Is to cross multiply. So 40 times 1 is equal to um that is, so we have 40 equal to what? 2r, right? So r equal to 40 all over 2 equal to what? 40, this thing divided by 2 is what? To give us 20, isn't it? 4 divided by 2 to give us 20. Now, okay, don't forget this, the unit. Now, this is the value of the resistance, right? Now, we can what? Now draw this diagram in this form. Yes, look at it. No space also, please. So we have 1.2a, right? Here we can draw this diagram in this form like this. Um, 20 ohm, right? Is 20 like this. Then to now be that is 12 volts by the V. So are you getting it now? Are you getting it? So this diagram, we have two resistors here before now, so that's why these two circuit is here. Are you getting it? So that's why we have to, the reason we have this these two circuit is because we have two what resistors here. That's why. Are you getting it? So now we are having only one here. So you can leave it in this form and continue with your calculation, but I'm just showing you example. Okay, so this is the second one because we are what? We have this thing calculated the value, that is the single resistance, which is what? 20. So you can what? Represent the diagram in this form. Okay, so please don't be confused. Now we are having one. Okay, no space, so I want to clean. If you have not written down these formulas, please do it fast. Pause this video and write down the formulas very fast. I want to clean everything. Okay, just forget about this part. I won't clean this part. Okay, I won't clean it, but just write down these formulas, only these formulas. So we'll continue. Okay, pause this video and write them down. Whenever you are given a physics equation to calculate, the first thing to do is what? Is to write out the given values so you can know the formula to use. Are you getting it? What I said, whenever you are given a physics equation to calculate, first of all, write out the given values so you will what? Easily identify the formula to use. Now, from this diagram or from this one, you are given what? This is current, right? We are given current equal to what? 1.2a. This A stands for ampere, which is the unit of what? Current. Okay. Here. Now we are given resistance, right? Which is R equal to 20 ohm. What else again? We are given time, which is T. Time equal to what? 5 minutes. 5 minutes, but in physics, you have to what? Convert it to seconds. Are you getting it? You have to what? Convert it to what? Seconds. Okay. So if you want to convert from minutes to seconds, you just multiply that given number by what? 60. You don't hear? If you are converting from minutes or hours to seconds, you are what? Just multiply that particular number by what? 60. So 5 times 60 will give us 300 seconds. Are you getting it? Now the last thing is what? We are given volts, which is the potential difference, right? Let us write V equal to what? 12 volts. Okay. Are we done? I think we are done. Okay. Okay. Now from um from the formulas, they said calculate the total energy. What did I said? I said when you are asked either calculate for the electric power or the energy, you can use what? Those formulas. Are you getting me? That's why you have to know those formulas in the exam. You will need either the first one, either the second one, either the third one, anyone. Okay, you have to know them. Are you getting it? Now, so if you check well, one of the formula is what? One of the formula is what? That is That is I square. This is the current, okay? So that one is not one, if you like. It's not one, it's I, okay? That is signifying the current. Are you getting it? I square, then R T, right? This is one of the given formulas. So I said if I have to calculate for what heat energy, okay, total energy, you can use those formulas. Are you getting it? So this is one of the formula I square RT. Are you getting it? So equal to, what is the value of I here? Is 1.2, 1.2. So you will square it, okay, since we have square on top. Then you multiply times the value of R resistance, which is what, 20, times time is what? Time is, okay, it's 300. It's 300. Now you press your calculator. This one is 1.2 into two places now. 1.2 times 1.2, I get it. Then times 20 times 300. So the answer will be 8640. And what is the unit of energy or heat energy is in what? Joules. So the answer is what? 8640 joules. So you see that the calculation is very simple, right? It's very simple. So make sure when you are solving this type of questions in the exam, you have to be very fast too. You go fast, okay? Because you are working with time. I get it. You are working with time. Okay, so please take note. Um, okay, let me give you guys the one I said. In case you don't in case you don't understand, you can refresh the video and restart again. Okay, please share this video to your friends. It's very important. Share this video to your friends. Now, um, okay, let me give you the last question so you can attempt it. Okay. Okay, so we have two questions here. The first question is very simple, Abby. Oh my lord. Look at the first one. They said calculate the combined resistance. You know these two are connected in parallel, right? These two are connected in parallel. Okay. So you know what to do. Yes, you know what to do. And then look at the second one. The headlamp of a car takes a current of 0.4 ampere from a 12-volt supply. The energy produced in 5 minutes is what? You know the formulas now, giving all the formulas you need in the exam. So please take note. So apply one of those formulas and make sure you do the proper conversion. You know what to do. You convert this time to what? This minutes to what? Seconds, have you? Then write down the values now. We are given this thing, current is given, time is given, volt is given. Know the formula to use already. See, in most of the calculations, it's not even compulsory that you must apply in some. Let me say this. The first one we calculate, this last question, we didn't apply that volt, right? We didn't apply that the volt. So you can notice that in most questions, it's not all the values we add in solving. That is simple truth. Now in electric circuits, I want to say something. um Let me say, in a circuit, the resistors, you know the resistors now, the resistors, the total, let me say, the potential difference, I getting it, is the same, okay, in all the resistors, which is the volts. I get it. It's the same in all the resistors, but the current is different. The current in this one is different from this one. The one in this one is different from this one. And the one in this one is different from this one. But the voltage, which is the potential difference, is the same in all the resistors, but the current is different. That's why we didn't add when solving. Are you getting it? Because but we added the current 1.2, right? We added the current, but the volt we didn't add it. So this is the reason. So you can write it down. Okay, in all the resistors, okay, the volt or the potential difference is the same in all the resistors, but the current is different. Are you getting it? So do the calculations and drop them on the comment section. please indicate number one answer is this, number two answer is this. Okay, and those of you that are in my lesson group, please also draw the answers in the interacting group. And in case you are interested in joining my Jamb lesson group, you can indicate on the comment section. I will send you my WhatsApp number. Okay. Oh, okay. Fine. Okay. Bye. Thanks for watching. Please share this video to your friends. It's very important to share this video. And make sure if you are watching on YouTube, subscribe. And if you are watching on Facebook, follow for more videos. I will be dropping videos back to back till the exam. Bye.